So we're going to talk about angle again, and angles have obviously two sides. That's how you make an angle, right? So then the side that we start, it's always going to be the positive x-axis. So this is the side it starts, and we call that initial side. So initial side is always the positive x-axis. So that side is not going to move, and the other side makes the angle. So that side that moves will make the angle, and we call that terminal side. So this is the side that moves, and this is called terminal side. So the initial side and the terminal side will make an angle. Okay, this angle, we're gonna, so there's a name, so this is a Greek letter, and it always means angle. The way you read it is theta. 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 Theta is the Greek letter for angles, basically. Okay, now, so this initial side never moves. The terminal side moves. If the terminal side moves this way, which is the counterclockwise, we call that positive. Okay, this side doesn't move, so if the angle goes this way, counterclockwise, it's positive. So this way is positive. If the angle goes below first, so clockwise, then that is called negative. So if the angle goes this way, it's negative. Okay, let's see how much you guys remember from Algebra 2. So can you give me 30 degrees with your hands? 30 degrees. Yeah, two hands though, because 30 degrees. About this much, right? What's another angle that is 30 degrees, that ends on the same side? What angle is that? So 30 degrees ends here, right? Initial side never moves. What's another angle that ends on that same side as 30? Negative 330. Okay, negative 330 is going to go negative direction. Okay, yes? What's another angle that ends on the same side? Okay, well, give me an angle.
690. Because you get negative 330 and add
720.
720.
Maybe add 720.
Add the same one.
Yeah.
Yes. Okay, so
was it 330 and then just add on that?
yes, not 330, negative 330.
Oh, it was,
yeah.
And then add
So right. So this is the initial side. This is the final side, right? Terminal side. If you want to end at the same side, you turn around this whole circle once. Right? So if you start at 30 degrees, you could go in a positive direction 360 degrees. So then where would you end up? At the same place. And what angle is that though? You said 390. Yeah, 390. So 30 degrees plus 360. Because you're going around the whole circle to get to the same place, right? Or you could subtract 360, right? 30 minus 360 is going to be negative 330. Yeah, okay. So angles that end on the same place, we call that coterminal angles. So if you recall co like co-pilot or co-worker, co means along with. So it's another angle that has the same side. Another angle that has the same terminal side, we call that coterminal angles, as long as they end on the same side. So angles that share the same initial and terminal side. Initial and terminal side. So you always add or subtract 360 degrees. Or, what's another way of saying 360 degrees in radian? Yeah, 2 pi. Or you can add or subtract 2 pi. Or multiples of them. So you can keep doing 360 forever. 360, 360, 360 for a long time, and you would keep getting the same angle. So let's practice. So we already did 30. 30 degrees, another coterminal angle would be like adding 360 degrees. You get 390 degrees. Or you can subtract 360 and you get minus 330. Can you guys give me a coterminal angle with negative 150? Yeah, 210. So basically, if you added 360 degrees, you would get 210. What's another one? Negative 510. So fast. Okay.
Oh, I already counted.
Oh, okay. All right.
I give people chance for this one.
Okay, 2 pi over 3. So remember, you're going to add or subtract 2 pi. Okay, give me one angle. Yes, Ashley?
8 pi over 3.
Yes, 8 pi over 3. Someone else. Sally?
Negative 4 pi over 3.
Good. All right. Now what we're going to do is we're going to think about these trigonometric functions in terms of angles. And to do that, we're going to look at this drawing again. So this is how most of the time we're going to look at this drawing. We're going to draw a straight line down from the terminal side. And that straight line down is going to make a perpendicular angle, creating a right triangle. So on this right triangle, we have 3 sides. 1, 2, 3. And this side that's on the x-axis, we're going to call that x. The side that's parallel to the y-axis, we call that y. And the side that comes straight out from the origin is called r. R for radius, because we're kind of talking about a circle, and that's the radius. So that angle is that angle that I show you. In terms of that angle, and in terms of x, y, and r, what is the sine ratio? Okay, so sine theta is what side over what side in terms of x, y, and r? Y over r. Opposite over hypotenuse. Are you guys with me? SOHCAHTOA. So remember SOHCAHTOA? SOHCAHTOA says so, which is sine, is opposite over hypotenuse. So y over r. Y over r. What about cosine? You might have to look at your drawing because x over r. What about tangent? Y over x. Okay, and then the reciprocal functions, they're all going to be reciprocal of the original functions. So just flip the ratios. So r over y, r over x, and then x over y. All right, now we're ready to solve some problems. Let theta be any angle in standard position. Standard position means that the initial side is on the positive x. So they're just like standard. This side doesn't move and then terminal side moves. In standard position, whose terminal side contains the point negative 5, 3. Find the 6 trigonometric functions of theta. Okay. All right. So the initial side is here. We just don't really have to care about that. The terminal side has the point negative 5, 3. So we need to find negative 5, 3. It doesn't have to be a nice drawing, just negative 5, 3 here. So they're saying that the terminal side has that point. So what we do is we draw a straight line from the origin to that point, because that's how the angle ends. And this angle is going to be this one. The question is, what is the 6 trig ratios of that theta? All right, this is a little bit tricky because we have never seen a triangle that is obtuse. It's always a right triangle with acute angles. So what we're going to do is we're going to draw the triangle from here. We're going to ignore that other one because the way that we have set up this ratio with, as long as we stick to the correct positive and negative values, we will get the same number, even though it's not actually looking at the same triangle. Okay. All right, long story short, whatever the angle is, it really doesn't matter. You just need to draw a right triangle from the point straight down to the x-axis. If you just evaluate that triangle, you will always get the right answer. Okay? All right. So we're going to ignore that angle there. I'm going to write another angle here, and I'm going to put a prime just so that we're saying it's not the same angle, but it's related. All right, let's figure out the sides. What is the value on this side? 5. It's length 5. However, we're going to the left, so we're going to say negative 5. So we're going to call this negative 5. What about this side? How long is this side? 3. What about this last side?
4. Wait, no, never mind.
How are you going to find it? Huh?
Square root 34.
Square root 34. So basically you did a squared plus b squared equals c squared. So negative 5 squared plus 3 squared equals c squared. 25 plus 9 is 34. So this is going to be square root 34. Yes? Okay, now we are finding the trig ratios. Again, like I said, ignore the other angle. Just focus on this triangle. So what is the sine of that new triangle? So focus on this triangle only. What is the sine of this triangle from this angle? Yeah, 3 over square root 34. Opposite over hypotenuse. What about cosine? Yeah, negative 5 over square root 34. That's why you had to put negative in there. We're not talking about the actual triangle. We're talking about this direction. It's negative. Okay? Tangent is what? Negative 3 over 5. All right. Now we go and do the reciprocal. So reciprocals are easy. Once you find the original 3, you just flip them over. All right, just to review. Whatever the question says, you first draw your initial position, and then you draw your terminal side to cross the point that they tell you it crosses. Then you draw a straight line down to the x-axis. That's going to create a right triangle. Do not draw to the y-axis. You're going to have totally the opposite values from everybody else. Straight down to the x-axis. That's going to create a right triangle. From that right triangle, you evaluate everything. Okay? It really doesn't matter where it ends. You always draw a straight line to the x-axis. Good? Okay. Let's try one. Same thing. This time you're going to end at 2, 4. They just want you to find cosine. So let me know when you have the answer. So the answer is 1 over square root 5 or if you rationalize it, square root 5 over 5. Any questions? Okay. Now let's see how good you are with your reference triangles from the unit circle. If you don't remember anything from your unit circle, please take out the unit circle from yesterday. We may or may not practice memorizing. You should try to practice memorizing at home. Huh? What did you say it was? Is it negative?
Because it's on the lower coordinates.
Yes, you are correct. Okay. Sine 315. Sine 315. So what you want to do is have an idea of a unit circle in your mind. So first, I just think 315 is over 180 degrees. So definitely on the bottom somewhere. So it goes 90, 180, 270. So it's past 270, so it's somewhere in the fourth quadrant, right? So 315, it ends in 5, so that's going to be one of the 45s. Okay, so it's definitely here. Sine, cosine is x. Sine is y. Maybe I shouldn't put x. Too confusing. So cosine is the x direction. Sine is the y direction. So the question is, how long is this? You have to remember that all your 45s are square root 2 over 2s. And so this is going to be negative direction. So sine of 315 is equal to negative square root 2 over 2.